Okay, now we'll learn what is Taylor series. If f of z is analytic at all points inside a circle C with its center at A, then for all z Taylor series about the point z is equal to A is f of z is equal to f of a plus z minus a by 1 factorial f dash of a plus z minus a the whole square by 2 factorial into f double dash of a plus z minus a the whole cube by 3 factorial f 3 dash of a plus etc. Then we have Maclaurin series. When you take a is equal to 0 in Taylor series. So Taylor series is equation number 1. So in equation number 1, when a is 0, we get the Maclaurin series. F of z equal to, so replace a by 0, f of 0 plus z minus 0 is z. So z into f dash of a by 1, f dash of 0 by 1 factorial plus z square by 2 factorial f double dash of 0, z cube by 3 factorial f 3 dash of 0 plus etc. So this gives the Maclaurin series. Laurentz series, let C1 and C2 be two concentric circles such that mod z minus a is equal to R1 and mod z minus a is equal to R2, where R1 is less than R2. So we know concentric circles means circle with same center, and the circle equation we know general form is mod z minus a is equal to R1 and the second circle mod z minus a is equal to R2, and radius of the first circle is less than the second one, that is R1 is less than R2. Let f of z be analytic on C1 and C2. So this function is analytic in the circle C1 and C2 and in the annular region between them. Annular region R, capital R, okay, annular region capital R between, this is between them. Then for any point z in R, so we take any point z in that annular region R, f of z is equal to, so we have the series expansion here, summation n is 0 to infinity a n z minus a whole raised to n plus summation n equal to 0 to infinity b n z minus a whole raised to n. So where a n is 1 by 2 pi I integral over c1 f of z by z minus a whole raised to 1 plus n dz, bn is 1 by 2 pi I integral over c2 f of z by z minus a whole power 1 minus n dz. So an you have 1 plus n, bn we have power is 1 minus n. So this gives the Laurentz series expansion with the values of an and bn given here. Okay, now we'll do a problem. Expand f of z is equal to cos z in Taylor series about the point z is equal to pi by 2. So here the solution, Taylor series about z is equal to a. So this is our general equation. Taylor series about z is equal to a is f of z equal to f of a plus z minus a by 1 factorial f dash of a plus z minus a the whole square by 2 factorial f double dash of a plus etc. So this is equation number 1. So now we consider f of z, okay, we take f of z. It is f of z is cos z. So what will be f dash of z? F dash of z is equal to, we know derivative of cos z is minus sin z. Then what is f double dash of z? Is minus derivative of sin z, it is cos z. So differentiate f of z to get f dash, differentiate f dash to get f double dash. Derivative of cos is minus sin, sin is cos z. So now at a is equal to pi by 2. At a is equal to pi by 2, let us find the values of these three equations, that is f of z, f dash of z, f double dash of z. When a is pi by 2, f of pi by 2, okay, it is here, f of pi by 2, that is cos pi by 2, replace z by pi by 2, replace z by pi by 2, cos pi by 2, cos 90 is 0. Then f dash of z is f dash of z, let us take z as pi by 2, okay, z is equal to a. So here instead of z we take pi by 2. So when sin pi by 2 comes, okay, it is here f dash of pi by 2 is minus sine pi by 2. Minus sine pi by 2. Sine 90 is 1. So here it is minus 1. Okay, then f double dash of pi by 2. So here instead of z we take pi by 2 minus cos pi by 2. Cos pi by 2 is 0. So this value is 0 here. So the thing is you should know cos 90 is 0 and sin 90 is 1. So that you get the values. Now let us substitute these values here. Okay, that's what we are going to do now. We are going to substitute these. So let us substitute the values here. That is we have derived f of pi by 2 is equal to 0, f dash of pi by 2 is equal to minus 1, f double dash of pi by 2 is equal to 0. So let us substitute it here. Okay, f of z is equal to f of pi by 2. We replace a by pi by 2 because Taylor series about the point z is equal to a. Okay, so a we take the point a as pi by 2 because it is given in the question about the point pi by 2. So you replace it, we get f of pi by 2 plus z minus pi by 2 by 1 factorial f dash, and also we get z minus pi by 2 by 1, then into f dash of pi by 2 it is minus 1. Okay, plus z minus pi by 2 by 2 because a is pi by 2 the whole square. So we substitute this in Taylor series formula. Okay, pi by 2 factorial whole square f double dash of pi by 2. What is f double dash? F double dash is of pi by 2 is 0. We have derived it into 0. So first term and the last term cube term is 0. We have only the second term here, that is we have 2. Okay, you may get the third term also if you substitute. If you continue like this, we get z minus pi by 2 the whole cube by 3 factorial into 1. So we can write minus z minus pi by 2 because we have a negative sign, minus z minus z by 2, z minus pi by 2. Okay, sorry, z minus pi by 2. Here also this is z minus pi by 2. This is z minus pi by 2 plus then the term is z minus pi by 2 the whole cube by 3 factorial plus etc. It goes on like this. This gives the Taylor series expansion. So similarly the next question sin is that you can do it on your own. Okay, so you can do the next. So answer to sin z is here. Okay, you have to write the Taylor series expansion. Then what you have to do is about the point pi by 4, instead of a you have to take pi by 4. Then you can differentiate f of z, find f of z, f dash of z, f double dash of z, 3 dash of z. Then you can find at the point pi by 4. Sin pi by 4 is 1 by root 2. Cos pi by 4 is also 1 by root 2. So if you have minus, then minus 1 by root 2. Minus sin pi by 4 is minus 1 by root 2. Instead of z you have to take pi by 4 and you have to write the value. Then you substitute it in the equation. Okay, substitute the value. Instead of f of pi by 4, f dash of pi by 4, f double dash of pi by 4, you substitute the value and you get the answer here. Okay, 1 by root 2 plus z minus pi by 4 by 16, 1 by root 2 into 1 by root 2 minus z minus pi by 4 the whole square by 2 factorial into 1 by root 2, the next term plus z minus pi by 4 the whole cube by 36 into 1 by root 2 plus etc. So this is the expansion. Then expand f of z is equal to 1 by z in Taylor series at z equal to 1. This also you can try it on your own. Write the Taylor series. Okay, you can refer to the Taylor series expansion. Okay, you can refer to this Taylor series expansion. Write this expansion. Instead of a you have to take 1. About the point z is equal to 1, right? So instead of a you have to take 1. Then you can follow the same steps. Okay, so you can differentiate f of z is 1 by z, that is z raised to minus 1. What will be f dash of z? We know derivative of x raised to n is equal to n into x raised to n minus 1, n into x raised to n. You can follow this method. Derivative of z power minus 1 is equal to n is minus 1. Minus 1 x power minus 1 z power minus 1 is minus 2. That is minus z power minus 2. So you get minus z power minus 2. F double dash means what you have to do? Minus. You can apply the same formula. Okay. You can apply the same formula, that is n into x power n minus 1. So you get, what is n here? Minus 2. So we get minus 2. Here you have a minus. Okay. Minus 2 z power minus 2 minus 1. So you get minus into minus plus. So here 2 minus 2 z power minus 2 minus 1. We get 2 z power minus 3. Similarly f3 dash. 2 into this is n minus 3 z power minus 3 minus 1 minus 4. 2 3s are 6, that is minus 6 z power minus 4. So now after f of 1, f of 1 means instead of z you take 1. Instead of z you take 1. F dash of z, f of 1, f dash of 1, f double dash of 1, f3 dash of 1. So instead of z you substitute 1, you will get these answers. So finally you substitute it in this general equation, f dash of 1, f double dash of 1. Okay, substitute it to get the Taylor series expansion. So you can do this. Okay, next question, expand f of z equal to sin z by z minus pi. This is pi. Okay, z minus pi. About z equal to pi in Taylor series. So f of z is sin z by z minus pi. Here by making an adjustment we can make it in the Taylor series expansion. This is an important question only. So you see sin z can be taken like this. Sin z we add and subtract pi, minus pi plus pi. Then what we do is we split this term sin z minus pi plus pi. Okay, we split the terms. So when you split, that is like this, sin z minus sin z minus pi plus pi. So now it is of the form sin a sin b. What is sin a sin b? Sin a cos b plus cos a sin b. So here we get the values. Okay, we get the values after writing sin a cos b plus cos a sin b. We know for cos pi the value is minus 1, sin pi the value is 0. So this second term will become 0, first term will become cos pi is minus 1. So minus sin z minus pi, minus sin z minus pi. So we get the numerator, this sin z becomes, okay, this is for sin z. Sin z is adjusted as minus sin z minus pi. So this term minus sin z minus pi. So after this what we are going to do, we know the equation of sin x, right? Sin x. What is sin x? Sin x is given by, you know, sin x is given by x by 1 factorial minus x cube by 3 factorial minus x power 5 by 5 factorial plus etc. So what we going to do, you see sin x. So instead of x we have here, what is the function z minus pi, right? Here we have instead of x we have z minus pi. So here sin z minus pi means what you replace all this x by z minus pi. So we get now 1 minus 1 by z minus pi is here. Okay, so we write minus 1 by z minus pi. Then sin z minus pi, just you replace it, z minus pi by 1 factorial minus z minus pi whole cube by 3 factorial plus z minus pi whole power 5 by 5 factorial plus etc. So we get after expanding this, you can write one more step that gives the solution, that is Taylor series